Assalamualaikum and hi to everyone. My name is Muhammad Muzamir and I will explain about the addition instruction in Cortex M0 Plus. So this is syntax for the addition instruction. ADD, S is optional, you can put it or you can ignore it. RD, register address is also optional. The first source and the second source register. As you can see here, it said when the optional RD register specified is omitted, it is assumed to take the same value as Rn. The example is like add R1 plus R2 is same with add R1 is address RD, R1 is RD, and R1 plus R2 is the source. So the resolution is been in this table. As you can see, RD and Rn must specify the same register. As you can see here, RD and Rn is same register. And the immediate value for this addition instruction is 0 until 255 because this microprocessor use the 8-bit. So let's see the example. Before I go for the example, I would like to go to the syntax error. Okay, let's build. As you can see, this is set two errors here. Okay, the first error is the RD and Rn is not in same register. So this must be R0. And the second error is the immediate value. It must be 0 until maximum 255. Okay, let's trouble it. So there is no error here. Let's go to debug. I have some example here. I load this R0, R1, R2, R3, R4, R5, R6, R7. Okay, for this add instruction, the first add instruction is the operation will be like R0 is address and R0 plus R1 and it will save at the R0 here. You see this register, it will change. So that's it. And the second instruction is same like the first instruction, but the register address is not here. The operation is like R2 plus R1 and it will save the answer at R2. The R2 will be changed here. The third instruction is ADDS. This S means it will update the flag here. The operation is the R6 plus R7 and it will save at the R6 here. You see the R6 will be changed. Yeah, and the flag for this add will be changed. Carry will become 1 and the overflow become 1. The fourth example is the hexadecimal immediate value. So the operation is R5 plus hexadecimal 45, and it will change to R5, and it will save to R5. So R5 will change. So the flag will be update. Carry will become 0 and overflow will become 0. And the last example is uh, the R5 plus decimal value 255, and it will change the R5 value. So R5 value will be changed here.
Assalamualaikum warahmatullahi wabarakatuh. Now I will explain about the ADC, the add with carry. So as we know from the manual Cortex M0, you can either put the instruction of ADC or ADCS. S is for the NV for the NZCV information or the flag. If the flag is up, it will update the S information here, either the N0, Z0, or carry is 0, or V is high. It's like that. So from the tutorial 4, I uploaded the value of register until register 5 up to here. Okay, I load the value of register, then I run on my own example. So as we can see here, the ADC known as I instruct the R7 plus R1 and install in the register R1. So then as we see here, the value of register is 400000A, and the value of register 1 is 09 A, B, C, D, F. So we can see here that if the carry from after 4 here is you can see from the as we can see here from the my manual calculation, the carry is 0. As we can see here, 4 plus 0 is 4. It's not exceeding 15 decimal, or we can see 16 or F decimal. So we can say that the total value of register 1 is 49 ABCDF9. So I have to run here. Okay, so see 49 ABCDF9. And the second example is RO R4, and RO plus R4 stored in the register RO. So as you can see here from the example here, I can see that say its value 8 plus 0 is 8. Oh, I'm sorry, 8. 0 plus 2 is 9. 6 plus 3 is 9. 5 plus 5 is 10. 10 in decimal, but in hexadecimal we call it A. So 7 plus 4 is B. 9 plus 3 is 12. 12 equals to C. B plus to D. 8 plus 1, 9. So no carry. Carry is 0. Okay, you can see here. So run. Oh, sorry. So there is the basic of the addition in hexadecimal. 9DCBA 998, 9DCBA 998. So for example C, R2 plus R3 here with S instruction. So it will update in SBCR. So from my manual calculation, it is 8, E plus 8. E plus 8, E equals to 14, plus 8 equals to 22. So 22, the maximum of hexa is F. F is 60, in hexadecimal is 16. So minus 16 equals to 6. 6 here. And the carry is 1. So C plus 9, C plus 10, C equals to 12. 12 plus 12 plus 10, 22. 22 plus 6 is same as before. 1, 1, 8. 11. 11, it must be 5. 1. 8 plus B, 8 plus 9 plus 11, 20. 20 minus 16, 4. 1, 6, 7. 7 plus 12. 12, 9. 9 plus 3. So 1 and 4. 4. D. 6 plus 13. 13, 3, 1. So you have to calculate if you want to see if the carry is equals to 1. You have to see at the most significant bit. As you can see here, 7 plus E must be carry must be high here because 7 plus C E equals to 14. 14 equals to 21. 21 minus 16 is 5. Okay, so it is carry is high here. Basically, this is 22. Right, 32 minus 16 is 6. You can see here, 623. Let's run it. 6, 2, 3, 4, 5, 6, 7, 8. So the carry is 1. And R3, R3, 4. And R3, R3, 4. R3 plus R4. So just see at the most significant by MSB. E plus 8. Even though the carry is 1 here, even though in case the carry is 1 here, you can say that the carry is still 1 here because we use the 8-byte system. So only 8 byte is allowed, so the carry is 1. E is 14 plus 8 plus 8 is 22. Even the carry is 1 here, it is 23. So 23 minus 16, it is 7 here. With the carry 1, you can see here, the most significant byte must be 7 here. See, the 7, the carry is updated here. And no overflow also. So thank you very much. Assalamualaikum warahmatullahi wabarakatuh. Now we'll be proceed to the RSBS instruction. So RSBS instruction is the opposite instruction of sub instruction, which means if sub R0, R0, R1, it means that R0 will subtract the value of R1 and store in the R0 register. Meanwhile, in the RSBS instruction, it means that R1 will subtract the value of R0 and store the value, the result, in the register 0. It is opposite instruction, right? It's explained here. Subset the Rn from the 0, producing Rn to negative. In case if the immediate value is 0, but if let's do some example here. So I've loaded the value of register R0 until R5 and we'll stop at line 75. So R0 minus R1, I'm sorry, R1 minus R0. It means that F minus 8, 60 minus 8, 50 minus 8, 7, 5, 4, 2, 0, E, B, 6. So 6. This is negative. Negative is 0. The flag will update and will be 0. Let's play here. Let's see CPSR. So N is 0. Okay, so the next example means that R4 minus R3 and the result will be stored in the register 3. R4 minus R3 is easy example. So f minus 8, 7, f minus 8, 7, f minus 9, 6, 1. So we'll see the result. And the negative value is the 1. Is the 0. Same, the negative is 0. So let's try to the next example, which includes the immediate value and the destination register. So let's try it. So it's 16. Immediate value of 16 in hexadecimal is 3c. Well, minus the value of R3. So my R3 is 1, 2, 3, 4, 5, 6, 7, 7. So C minus 7, 12 minus 7, 5, 3 minus 7. Oh, it will borrow the value of negative value. So it will be 16 minus 3, 19 minus 7, 12. It will be C. Okay. So this is 15. 15 minus 6 equals to 9. 15 minus 5a, 15 minus 4b, 15 minus 3c, 15 minus 2d, 15 minus 1e. Why 15 here and why 16? Because 15 is already borrowed by here, LSB here. So that's why all this value is 15 and the result is here. So this is E. E is 1110. It means that my n will be updated here to 1. Let's play. So as expected, the result is same. So let's proceed to the next example. So the 0 will subtract the value of R5 and the result will be restored in the register 1. Let's try it. So 0 as a example as in previous example. So 0, this is 16, 15, 15, 50, 15. This all have been borrowed by this. So 16 minus 1 F E F, because 0 minus 1 is E F, and it will produce the negative result, negative flag update to 1, n equals to 1. So let's see E F. Let me explain once again. Because 0, you will need to borrow here, it will need to borrow it up to here. So this is 15. The 9 bit, we only need 8 bit. Okay, so this have been 16 will be forwarded up to 15. So the result will be EEF.
Hi, we are going to see the instruction set Cortex M0 Plus, which is sub. Sub or subtraction is the operation of the minus of either 3 operand or 2 operand. We go to we see the syntax here. Sub, and then followed by S. S is optional here, and then followed by RD, followed by RN, and followed by RM or immediate. S calls sub instruction to update flag as here, and RD is the specifies the result of the register, RN the first source register, RM specify the second source register, and IMM is immediate, specify a constant immediate value. So we go to the first example, which is 2 operand. We load R1 with 5, 6, 7, 8. Then we load R2 with 1, 2, 3, 4, and we sub R1 with R2, and the result we get will store at R1. So something like this in the kill software. So we go to the kill software. So we load R1 here with 5, 6, 7, 8, and then we load R2 1, 2, 3, 4, and we sub R2 with R1, R1 with R2, and the result will store at R1. So 1, 2, 3. Yeah, the result get 4, 4, 4, 4. So we go to the calculation manual to confirm the result. So R1 is 5, 6, 7, 8. R2 is 1, 2, 3, 4. Right. 5, 6, 7, 8. 1, 2, 3, 4. 5, 6, 7, 8. 1, 2, 3, 4. So we split the binary number 1, 1, 1, 0, 0, 1, 1, 0, 1, 0, 1, 0. So here 1, 0, 0, 0. Here 0, 1, 0, 0. 0, 0, 1, 1. 0, 1, 0, 0. Alright. So same, right? So we subtract R1 with R2. 0 minus 0 get 0. 0 minus 0 get 0. 0 minus 1. We borrow from this side. Here we get 0. And here we get 1 and 1. So 1 minus 1 here we get 0. But have another one. This another one we put at here 1. So here 0 minus 0 will become 0. Here 1 minus 1 become 0. 1 minus 1 become 0. 1 minus 0 become 1. And 0 minus 0 become 0. Then here 0 minus 0, 0, 1 minus 1, 0, 1 minus 0, 1, 0 minus 0, 0, 1 minus 1, 1, 0 minus 0, 0, 1 minus 1, 1, and 0 minus 0, 0. So we convert binary to hexa 0, 1, 0. So 0, 0, 1, 0, 0, 1, 0. So the result is 0, 8, 4, 4, 4, 4. 0, 8, 4, 4, 4, 4. Same. So next we go to the second example, which is 3 operand. It same like example 1, but the difference here is we sub with the number immediate number. So we load R3 with 2323. We load 1, 2, 3, 4, and then we sub R3 and minus with immediate 2. We go to the kill. So here we load R3 with 2, 3, 2, 3. We load R4 with 1, 2, 3, 4. And then the result is 2, 3, 2, 1. So the third example is 3 operand, which is RD, RN, and RM. So here we load R4 with 2323, we load R5 with 1234, and we minus R5 with R4. So we go to the kill, load R4 with 2323, load R5 with 1234, and we sub R5 with R4 and result at R3 here.
Assalamualaikum warahmatullahi wabarakatuh. Next, I will explain about SBCS. Okay, SBC, which is subtract with carry. Okay, for the syntax, we must put the S in the kill to update PSR. And the destination register is mandatory to put. Okay, for the operation, the SBCS instruction subtract the value of RM from the value in Rn, deducts another one if the carry flag is set. It places the result in the register specified by RD and update the NZCV flag, which means if the carry before the SBCS instruction is 0, the result is reduced by 1. But if the result for carry is 1, it is not reduced. So let's go to the kill. Okay, here is the simple coding. Okay, we have to check, and there is no error. Continue to debug. Okay, load. Okay, for the sub instruction, this means R0 minus R1, and the result will place at the R0. Okay, so 9DCBA998 minus 09A BCDEF. Okay, this is the manual calculation, and from the manual calculation, I get 941FDBA9. Okay, so here the result is same, and at the PSR, the carry is 1, so we don't have to reduce by 1. Okay, for the SBCS instruction, R0 subtract with R1, and the result placed at the R0. So here is the manual calculation. 941FDBA9 subtract with 09ABCDEF and get 8A740 dBA. Okay, we get the answer placed at R0, and we check the carry is 1.